Hello everyone, welcome to Triaright, the new era of learning. This is Pack 365 in Module 6. Today we're going to learn about polynomial regression. In yesterday's lecture, we learned about this and now in practical way. So let's begin the topic part B. So we know the definition as usual. Polynomial regression is a form of linear regression where the relationship between the independent variable x the dependent variable y, right? So is modulated as an nth degree polynomial. It is useful when the data exhibit a non-linear relationship, allowing the models to fit the curve to the data. Okay, so here we have Python has a method for finding a relationship between the data points and to draw a line of polynomial regression. We will show you how to use this method instead of going through the mathematical formulas. In this example below, we have restricted 80 cars as a way passing through the center tool ball. So we have restricted car speed and the time of the day hour to the passing hour. Okay, we have example and then x-axis represent the hours. Okay, of the day and the y-axis represent the speed. So here the example we have doing right now. So if your data points clearly will not fit a linear regression, a straight line, all the data points. It might be idea for polynomial regression. Polynomial regression, like linear regression, uses the relationship between the variables x and the y to find the best way to draw a line through the data point, right? So we have to print this output like this because it is a perfect polynomial ideal, okay? So we want to print this perfect polynomial ideal. So for that, we want to move to the Jupyter. So for that, we are moving to the Jupyter. So it is best to creating dealing with the it is best for dealing with machine learning algorithms. So let's start. For that, we want to import NumPy, and then we want to import matplotlib, NumPy for numerical calculations. Okay, matplotlib for visualizations. So reality we are assigning the plot. Sorry, py plot. I want a py plot as plt. Okay. Now we are done. So now I want to create the array of the represent value. Okay. So now I want to create the array of represent value for x and y. Okay. So take x equal to here take some values for x in list. So we're taking array in. Okay. So for that we take 1, 2, 3, and 5 like that. We can just we're simply leaving some of the values because we do not want to form a proper curve line. Okay. 7, 8, 9, 10, 12, 13, 14, 15, 16, 18, 19, 21, 22. And for y, I am taking 100, okay, 90, 80, 60, 60, and 55 again 60, and again 65, again 70, 75, 76, 78, and 79, 90, and 99, 99, 100. I take it like this, okay? So we assign the arrays here. So now the time for the NumPy calculation. Okay. So NumPy has a method that let's us take the polynomial model. So we create a my model NumPy dot plt. NumPy we have polynomial, right? So poly. So NumPy poly 1D. So here we take NumPy dot poly. This is for the fit. We have polyfit for what x and y. Right? And we give it an testing as 3. Term. Okay. So now it's rectangle. Now my line equal to NumPy, right? So then the specific how the line will display. Okay, we start the portion one and to up to the end of the portion 22. So start portion one and 22 and end will be 100. So and end at the position is 22. So we taking 100 here. So NumPy dot line line space. Okay. So 1 comma 22 comma 100. Okay. So here we can draw. So now we want to draw the original plot here. Okay. Now we want to draw the original plot. We can see we can draw. So your original plot we can take as plt dot scatter plus x comma y. Okay. So see how the data points arranged. Now we want to deal with the uh, we want to deal with the line of curve line of polynomial, right? So here we take the my line comma we assign my model here my model my line. Okay. Now here so with final touch plt dot show. No, it's fine. So it will display the diagram. See how curve line it is. So here we can see that. So we have the curve line here of my line according to data. So either data. So we combine this both. Okay. So now we take the combine this both here. We and let's combine these two. Now see. So the data will arrange how the data. So here we only scatter dots. We take the scatter dots of the data set. So here we take the model line of the curve of polynomial line. So this is how actual data represent. Okay. I hope you guys understand. The linear means straight line and polynomial means curved line. So I hope you guys you understand about this topic. Thank you all.